Okay, in this video we'll be starting to look at factorizing quadratics, which is very useful for things we'll do later. Quadratics being those expressions with x square in them as the biggest power of x. Now, remember, factorizing is the opposite of expanding. So the first thing we want to do is review quickly how expanding works so we can properly reverse engineer that to see how factorizing works. Okay, so x and x give x square. 3 times x gives 3x, 2 times x gives 2x, and 3 times 2 gives 6. So to simplify that, 3x plus 2x is 5x, and everything else comes along. This gives the simple case where there is no number in front of x squared, as you can see there. That's when the quadratic is called a monic one. And again, what we've just done is called expanding. What we'll be wanting to do is to go backwards, which is called factorizing. There's all our language done. So how do we do that if we're just handed this end result here? How do we go back to making brackets that work out just right? So we need to think about what's special about the 3 and the 2, those numbers that go in the brackets. Okay, the first thing is that when you expand, these two numbers will always multiply to arrive at that constant number. So in this case, 3 times 2 was the 6. On the other hand, when you add these two numbers, what you arrive at is that middle number there, that 5. Okay, and it's clear that this is always the case for these monic quadratics. If you look back at the first expansion, okay, we see that it was indeed the 3x and 2x that added to give a total of 5x. So to factorize these monic quadratics, the ones where there's no number in front of the x, you just need to be able to fill in those two yellow numbers, and these will always be a pair of numbers that multiply to arrive at the constant and add to arrive at the middle number. Okay, it's often easiest to think in that order as well. Scan through factors of the constant, pairs of numbers that multiply to arrive there, and then pick out the pair that adds to the middle number. If none of them work, then have a cry, and then try again, because all your work should be rigged to work out nicely. We'll learn how to deal with the case when it doesn't work further down the track. Okay, so let's end with a couple of examples involving negative numbers, because it makes things a little different. Note, when you're doing this for real, there's pretty much no working out. Okay, what I'm going to show on the screen now is really stuff that should be happening inside your head. Okay, the aim is to get quick with this stuff, so it's helpful to not need to write it out every time. Okay, so what's happening on screen is really what should happen in your brain. So first number to look at is a constant here. We're thinking numbers that multiply to 12. So we have 1 and 12, 2 and 6, 3 and 4. Okay, knowing your times tables will be kind of helpful for these. But we need a pair of numbers that adds to -8. And the only way to get a negative is if both factors in our pair are negative. Because that way when you multiply, it's still going to be positive 12. But when you add, it's going to pop out a negative number. Okay, so now -1, -12 add to -13, -2, -6 add to -8, -3, -4 add to -7. Our target was -8, see that middle term there? So that means we must take -2 and -6. So they go in the brackets like that, and we're done. Okay, one more. We'll start with the constant again. And I know we need to find numbers that multiply to -20, but let's just ignore the negative for now and list all the sort of times tables, everything that multiplies to 20. So 1 and 20, 2 and 10, 4 and 5. Because they need to multiply to -20, that means that one of the numbers in our pair has to end up negative. And we can actually see which one quite easily by looking at the middle number, which here is just +1 because there's a single positive copy of x there. But the important thing is that it's positive. So when we look at our factor pairs, we need the bigger one to be positive and the smaller one to be negative, so that when they add, the positive one wins and the result ends up being positive. Okay, so now 20 minus 1 is 19, 10 minus 2 is 8, 5 minus 4 is 1. Our target was just the one copy of x, so it must be the bottom pair there. So we put in x minus 4 and x plus 5, and we're done. This whole thing becomes pretty automatic, I hope, with practice. Again, you really shouldn't need to write anything down when you're doing this for real, but I hope the thinking behind it is hopefully clear to you. So have a go yourself, and I'll see you around. Thanks.